Hello everyone, it's time to learn macroeconomics again. Today we are going to talk about Chapter 7, Part 1, Consumption, Saving and Investment. For this part, we have 4 targets to reach. The first thing is that I want to teach you what is the household budget constraint. And then secondly, we are going to learn capital depreciation, how do we model it, and then we'll move on to intertemporal choice, and finish with returns between different assets. For you to understand the material in this part, you need to read Chapter 7 in our textbook.
We first start from household budget constraint. For the household budget constraint, we assume there is a saving bucket, and each year there is some income flow that come into the bucket, and the household have to think about how to spend it. And the remaining money that's unspent will be for saving. To think about the income source, we assume that there are 3 different income sources. One is from labor. For each period of time, households supply L units of labor, and for each unit of labor, the wage rate is W. So the household would receive wage income of WL. In addition, households also own capital, which means machine. Then if the household owns K unit of machines, then each period the household can rent his machines to some firm, and the firm will pay rental price R for each unit. Totally, household will receive the rental income for capital, which we call it capital income RK, in each period. Then for the last, the household can also hold some kind of bond, which means the money the household lent to other people from the previous period. So suppose the household lent B dollars amount of money to some other people, then given the interest rate is R, then for this new period, this B unit of lending can generate IB unit of interest income for the household. Therefore, there are 3 income sources in this scenario. Totally together, that will be your total income flow for each period. Given the total income flow for this period, the household always have to think about how many consumption basket to buy, which is the decision of C. C here represents the number of consumption basket. Given each basket costs you P dollars, then the total consumption expenditure will be P times C. Therefore, if we minus income by consumption P times C, which would be the remaining balance that we can use for saving. We assume that there are 2 possible saving schemes. One is through investment in capital, which means buying more machine. So if you buy more machine, the number of machine you hold will increase. The other investing or saving scheme would be lending out your money, which means buying bonds. So if you buy more bonds, then at the end you have more bonds that can generate interest for you. Starting from the first saving scheme, and here we would like to introduce some notation. We use K to represent the number of machines that the household owns. So K now means the number of machines that the household owns now. Here it's equal to 1. And if the household use the money to buy 2 more machines, then in the future, the K future will be equal to 3. The difference between future and now will be equal to 2. Here we use delta K to represent the increment of machine capital that the household owns. We assume that each machine will cost the same amount of money as each basket of consumption. Therefore, they all will be charging a unit price of P. Given the household decided to increase its capital holding for 2 units, which means delta K equal to 2, then to do that, the household has to spend P times delta K amount of money for capital. which we call capital investment. The second saving scheme will be buying bonds. So we use the notation B to represent the amount of bonds that the household owns. So B now equal to 1,000 in this case, which means the household actually own $1,000 bond before the starting of now. If the household decided to put more money into bonds, then for this case, the B future will be 4,000. The change of B, we use the notation delta B, will be the difference between these two, which is 3,000. Then the 3,000 increment will be called financial investment for the household. In summary, whenever we have the total income flow, WL plus RK plus IB, the household can use them either for consumption or for saving. And for saving, there are two possible saving schemes. One is capital investment, which would be the price of capital machine times the change of capital unit, delta K. The other saving scheme would be financial investment, which means the change of bond balance that you are holding. So in general, we have this piggy money, which represent income flow, that has to be equal to the sum of these three possible expenditure and saving. So on the left-hand side is the budget constraint representing the income flow of the household. And on the right-hand side will be the outflow, which can come from consumption or capital investment or financial investment. Our previous setup did not consider the case that capital or machine will depreciate. So we have to consider capital depreciation in our model. The way that most economic theory consider depreciation is to consider the case that, like this car, if you did not fix it or maintain it, after a while it would turn into some kind of junk. So how do we model this kind of a depreciation process? The way we think about it is to consider a depreciation rate delta. So if there is a depreciation rate delta, which means that after you use the car for one period, we imagine that delta portion of it will disappear. Therefore, if you have a K units of cars, then the delta K units of car will disappear. We call it depreciation. And then in order for this K unit to function normally, you have to buy delta K units for replacement. In other words, if each unit costs you P dollars amount of money, then you have to put down a replacement investment of delta K times P amount of money for this part of maintenance cost. Therefore, then the whole car can function normally again. So if we consider capital depreciation in our model, then the three part of expenditures, the middle part, capital investment, has to include replacement investment, which is equal to P times delta K. So our household budget constraint would be modified as the bottom equation. In addition to that, there are two parts of investment related to machines. One is capital investment, the other we call it replacement investment. But actually, to be more precise, capital investment here, we actually call it net investment. And if we sum these two together, then we call it gross investment. So we always have to bear in mind gross investment is equal to net investment plus replacement investment. Now we move on to another topic, which is intertemporal choice and saving. Here the word intertemporal means that anything involved with more than one period. So if you consider some choice between today and tomorrow, then that would be called an intertemporal choice decision. A typical one would be like this. Every period we have some income flow into the piggy money, and then we always have to think about how to use it. For a typical household, he might think about withdraw P dollars of money out of the bucket, and then one way to use this is to buy the consumption basket. The other possible choice of using these P dollars is to buy a unit of capital machine. So what's the difference between these two choices? For the household, he knows that if he buys one consumption basket, he will feel the happiness from consuming it directly. However, if the household buy one unit of capital machine, that is called investment, actually the household does not feel happiness immediately. Then why bother to choose machine instead of consume the money immediately? To understand that, we have to think about tomorrow. Because if the household bought this unit of machine today, then tomorrow he has two options to maximize the return for consumption from this unit of machine he bought today. One is to look at the rental market. The household can put this unit of machine in the rental market for rent, and the rental price is $R. Then in this rental market, there will be a firm that decided to hire to rent this machine from you. So the firm will pay you $R and in order to use your machine for one period. Remember, this is a rental market, so after one period of usage, the firm has to return the machine to you. However, we know that machine would depreciate after usage. Therefore, delta portion of this unit of machine would disappear. And what the household can do for consumption from this depreciated machine is to sell it in the machine sales market. So what the household can do further would be to put this depreciated machine to the machine sales market, and the sales price here would be P times 1 minus delta, because now the unit of machine you are selling is not one unit, it's 1 minus delta unit. Therefore, the for sale price will be only P times 1 minus delta. And then in this machine sales market, there will be another household who is willing to buy it. Then this household has to pay you P times 1 minus delta dollar. So totally you would get R dollars from rental market, and then P times 1 minus delta dollars from machine sales market. This is the maximum amount of money you can get tomorrow from today's purchase of one unit of machine. So, in summary, if we buy one unit of machine today, then tomorrow our piggy money would increase by not only R dollar of rental income, but also P times 1 minus delta dollars of resale income from that unit of machine you buy today. Then you can use this amount of money to buy consumption basket tomorrow. And how many baskets you can buy, you simply divide the total income return from this machine tomorrow divided by P. So you would get R plus P times 1 minus delta divided by P units of consumption basket tomorrow. This will be the amount of basket that you can get tomorrow for consumption from the unit of machine you buy today. So, in other words, when we consider consumption today versus buying one machine today, then actually we are comparing consumption today for one unit of basket versus the possibility of consuming a basket of R divided by P plus 1 minus delta unit of consumption basket tomorrow. So actually the investment you did today is actually a consumption choice tomorrow that you are going to get. So actually consuming today versus consuming tomorrow, this is an intertemporal consumption decision. You are weighing one unit of consumption today versus R divided by P plus 1 minus delta units of consumption tomorrow. Of course, to consume tomorrow that amount of a consumer basket, you have to do it through investment today. So a household would try to balance these two intertemporal choices so that he feels indifferent. Now we consider a scenario. Suppose there's something happens so that the R divided by P, which is the real rental price. Suppose this real rental price increase. What does that mean? How does that affect households' intertemporal consumption decision? First, we know that if the real rental price increases, then any 1 unit of investment today would give you more basket of consumption tomorrow. Therefore, the original balance would be disturbed. You would start to feel that consumption tomorrow would become more attractive. Therefore, you should decrease today's consumption in order to invest or save more to get more consumption tomorrow. So what we will see is that in this figure, if we plot the future real rental price on the vertical axis and the consumption basket today on the horizontal axis, then higher real rental price would make you want to consume less today and consume more tomorrow. In other words, your consumption choice point would move from the bottom right to the upper left. We call this kind of change of consumption an intertemporal substitute effect on consumption. So it is the substitution effect of substituting today's consumption for tomorrow's consumption. And it is intertemporal because it is involved with 2 periods of decision choices. So we always have to remember the term intertemporal substitution effect, and we'll use this term constantly in the future. Now we move on to discuss the return between capital investment and financial investment. We know that for income flow, we have income from labor income, and we also have 2 possible income sources from assets. And there are 2 types of asset. One is a capital asset, which gives us RK. The other is financial asset, which gives us IB income. And so when we have all these 3 income flow come together, and we know that for the budget constraint, we have to think about how to spend it, which is our consumption part. And the part that's unspent will be called saving, and the saving can be divided further into capital investment and financial investment. And capital investment, we learned that it can be divided into a net investment, which is P times delta K, and the second part is the replacement investment, which is P times delta K. And now we want to talk about how does a household set aside its saving money to allocate it between these 2 possible investment options. To understand the allocation of assets, we think about the case that suppose the household already decided to save P dollars. Then one way of saving is to invest it into buying 1 unit of capital. And we know that for a unit of capital, it will give us the rental income R dollars tomorrow, and also tomorrow we can resell it and take back the income of P times 1 minus delta. Therefore, if we decide to save this P dollars in terms of investing in capital, then we would have a net capital investment return of R plus P times 1 minus delta. However, the other possible choice of saving is to buy bonds, which means you lend it to some other people. And if you lend to some other P dollars amount, then given the interest rate I, then tomorrow you would be able to take back 1 plus I times P dollars. So for a household who has P dollars amount of money to save, he has to balance between these 2 types of investment choices. The way he balances it would be looking at the investment return between these 2 options. And now we want to divide the average thing on the slide by P, which would give us the investment return of investing $1.
for both options. So if we divided by everything by P, then the net capital investment return for $1 of investment would be R divided by P plus 1 minus delta. And the financial investment returns of investing $1 on financial bond would be 1 plus I. So once we have the investment return for $1 for both investment options, then we can move on to look at the portfolio allocation problem that the household is facing when he considers saving. Okay, suppose that the household already decided to put 3 piles of cash on capital and 4 piles of cash on bond. And suppose that originally the return for these 2 assets are the same. And now we assume that something happened which make the return on capital become higher than the return on bond. Then what would be a rational household do to his portfolio? A rational household would reallocate the money he set aside for these 2 options. A natural way to do is to move more money from the bond part to the capital machine part, because now machine gives you more return. By doing so, you actually would be able to buy more machines. However, you will hold less bonds. And what would happen to machine relevant markets and to the bond relevant market? First, if household hold more machines, which means that next day in the capital machine rental market, the supply for capital rental will increase. Now there are more people willing to supply capital machine for firms to use. What will happen to the rental price is that then the rental price for capital machine will encounter a force of dropping. On the other hand, in bond market, if there are fewer people willing to lend money to borrower, and of course, if anybody who want to borrow money, he has to offer an interest rate that is higher than before. Therefore, altogether, we know that when the returns on capital is higher than the return on financial asset, the reallocation of portfolio choices among households would create a driving force that would drive down the capital machine rental price, which would drive down the capital investment return. At the same time, it would drive up the interest rate for bond. Therefore, the financial investment return would go up. So, following the same logic, we know that in equilibrium, the portfolio choice among households would drive the market force toward the status that all the asset investment return should be equal. Otherwise, there will be a further adjustment in households' portfolio. So what we get so far is that in equilibrium, it doesn't matter what kind of asset you invest in your portfolio, how you shuffle around your portfolio choices. It doesn't matter because all the options will give you the same rate of return. What's good about this is that it will make us tracking the asset accumulation much easier. Suppose we use A to represent the total asset or wealth of a household at the end of the period. And we know that asset can be divided into 2 types of assets for any given household in our model. One is the capital asset, and its value will be P times K. K represents the units of machines you own. The other asset is bound asset, whose value we use the notation B, which represents the amount of bonds that you hold. And so far we know that for any dollar value that you have on capital asset, $1 capital asset value will give you a net capital investment return of R divided by P plus 1 minus delta. Also, we know that for any $1 value you have on bond, it would give you a financial investment return of 1 plus I. So both returns are for $1. Therefore, to understand how much money you will get in the next period from your asset, we have to time everything by the asset value that you have for each portfolio option. Therefore, the total asset that you are going to have tomorrow will be PK, the capital asset value, times the net capital investment return for $1 in that asset, plus B times the financial investment return for $1 financial asset. It will be the total asset value that you are going to get at the beginning of tomorrow. And from the equilibrium condition, we know that we can simplify the net capital investment return to 1 plus I. So by doing so, actually the part of total asset tomorrow related to PK, the term in front of it can be simplified to 1 plus I too. So we now have a 1 plus I as the investment return for both portfolio options. So what does that mean for us to track our asset value evolution? We know that at the end of the day, any household will hold a total asset value. We use A to denote the value. And we know this A value comes from a portfolio of two types of assets. And A is simply the market value of each asset. When you sum them together, that will be A. And then if you are holding an asset value of A, and by the end of tomorrow, by the beginning of tomorrow, not the end of tomorrow. So at the beginning of tomorrow, you can get back not only the value of A, but also it will give you extra income that represent the asset return income, and it is simply I times A. Notice that here we only use the total market value of your asset A to derive the asset return income. We don't have to worry about how the detail of A is. We don't have to worry about whether 50% of A come from capital machine or 20% of it come from capital machine. It doesn't matter, because at the end of the day, if the market is in equilibrium, then both options will give you the same rate of return. So with this feature, we can rewrite our household budget constraint in a much easier way, especially for the income flow part. Now, when we think about a household budget constraint, in each period, we can think about the labor supply that the household supply to the labor market, L units. Given the wage rate W, the household in this period will be able to obtain labor income of WL. In addition to that, household might have some asset left from yesterday. So given the value of the asset left from yesterday, and we know that any kind of asset altogether, they will carry the same rate of return, I, which represent the interest rate, then which means that each period, the initial asset value is able to contribute an asset return income of I times A to the household income flow. So together, we'll know that in each period, the income flow to the piggy bucket will be WL plus IA. And again, when the income flows in, there will be expenditure flow out, P times C, and the remaining part will be used to save, which means that the household uses to buy asset. We use a notation big delta A to represent such kind of asset purchasing. So here the household income budget constraint would be much simpler than before. Now you simply have the income flow on the left hand side to be WL plus IA equals to the expenditure side PC plus the saving, which is delta A. If you compare it to the old budget constraint of the household, you can see that the new budget constraint is much simpler than before.